Before moving on to the next question, we will be discussing few concepts that will be useful in finding the solutions in the problems ahead. So first one is equation of the coordinate planes. So we have three coordinate planes: yz plane, zx plane, and xy plane. So as you can see, these are the three coordinates. So let's take yz plane. What is yz plane? So yz plane is nothing but this. If you take any point in this yz plane, you can see that the x coordinate of that point will be 0. That is the reason why the yz plane can be uh, defined by the equation x is equal to 0. So you shouldn't get confused here. This is the equation of a plane. So equation of a general form of an equation of a plane is ax plus by plus cz plus d equal to 0. So here b, c and d are 0 and a is equal to 1. That is how we get the equation x is equal to 0. In three-dimensional geometry, x is equal to 0 represent yz plane. Similarly, if you see if you take the zx plane, you can see that all the if you take any point in the zx plane, the y coordinate of that point will be 0. That is the reason why we have written the equation of the zx plane is y equal to 0. Similarly, for xy plane, z is equal to 0 is the equation. So I hope you understood this. And once you are clear with this topic, we can make a slight extension and find the equation of a plane parallel to yz plane. Let me just clear this picture and draw a new picture. Coordinates x and z. So equation of a plane parallel to yz plane. So yz plane is, as I said, we will construct an equation of a, we will construct a plane like this, which is parallel to zy plane. So this plane can be defined by the equation x is equal to a, where this point, where if you see all the, if you take any point in this plane parallel, which is parallel to zy plane, that will have a constant value for x. If x is equal to 0, then that becomes the zy plane, and for an x is equal to a constant, we can construct many planes that are parallel to zy plane. So any equation of a plane parallel to yz plane is x is equal to a. Similarly, you can visualize the other equations. Equation of a plane parallel to zx plane will be y equal to a, and equation of a plane parallel to xy plane will be z is equal to a. So these are the equations of coordinate planes and planes that are parallel to coordinate plane. So next is equation of a plane perpendicular to the coordinate axis. So let me just draw the axis here. Let these three be the axis. Call this x, y, z. So any plane which is parallel to yz plane will be perpendicular to x-axis. So let's consider this yz plane. As you can see, this yz plane is perpendicular to x-axis, as this is 90 degree. This is perpendicular, or we can say that we can say the normal to this plane. Normal to this plane will be parallel to this x. So direction ratios of these normal and the x-axis will be same. And any plane which is parallel to this yz will be perpendicular to x-axis. So as you can see, I just constructed a parallel plane like this to yz plane, and this yz plane will be, this plane will also be perpendicular to the x-axis. So we discussed that scenario here. Equation of any plane which is parallel to YZ plane is nothing but x is equal to a. So a plane that is represented by x is equal to a will be perpendicular to x-axis, as you can see here. So perpendicular to the equation of a plane perpendicular to x-axis is equation of a plane parallel to YZ plane, both are same, and it is x is equal to a. Similarly, perpendicular to y-axis will be a plane perpendicular to y-axis will be parallel to zx plane, and the equation will be y equal to a. And plane perpendicular to z-axis will be plane parallel to xy plane, and that equation will be z equal to a. So you can just try drawing the figure, and you will see the equation of these plane equation represented by these the planes represented by this equation will be perpendicular to these axes respectively. So we have discussed the equation of coordinate planes, the equation of planes that are parallel to the coordinate planes, and equation of the planes that are perpendicular to the coordinate axis. Such statements will be given in the question, and you can use this information to solve such questions. Next topic is angle between two planes. So we have two planes here. Let the equation of two planes be a1x plus b1y plus c1x plus d1 equal to 0, a2x plus b2y plus c2z plus d2 equal to 0. I have drawn two random planes, random bisecting planes here. So to find the angle between these two planes, what we need to do is, like, from a point we need to draw normals to these planes. Okay, so let these be the normals. Normals means perpendicular to the plane from these points. So we will from a point we will draw the normals, and the angle between these normals will be same as the angle between these two intersecting planes. So we just have to find the angle between these two normals to find the angle between the two planes. Now if you have gone through the general equation of the plane before, the direction ratio of the normal to the plane can be given from this equation directly. The direction ratios of normal to this plane will be a1, b1 and c1. Similarly, direction ratio of normal to the plane 2 will be a2, b2 and c2. So we have the direction ratio of normals here. So the direction ratio of any normal will be this. So direction ratio of this line will be a1, b1, c1, and direction ratio of this line will be a2, b2, c2. So to find the angle between these two lines, now it's simple. We just need we need to use the formula cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into of a2 square plus b2 square c2 square. So we just need this formula. If you have gone through what direction ratios are and finding the angle between two lines, you will easily understand this formula. Otherwise, please refer that portion. If you have any doubts also, please comment under this video. So yeah, so this will be this theta will be the angle between these two planes. When we have the angle between two planes, we can easily come up with the condition of perpendicularity of two planes. I'll just write down condition for perpendicularity. So we have cos theta is equal to this formula. So if the planes are bisecting in a perpendicular 90 degree, if the planes are perpendicular, then theta will be 90, or cos theta will be cos 90 will be 0. So cos theta equal to cos 90 equal to 0. That implies from this equation, numerator has to be 0. That implies a1 a2 plus b1 b2 plus c1 c2 equal to 0. So if you see, if we have two planes and in a general form, and if we need to check whether these two planes are perpendicular to each other, we just need to find a1 a2 plus b1 b2 plus c1 c2 is equal to 0. And how that comes is through this formula, the angle between the two planes, and we have this equation. So we can, from this we will have this. And similarly, condition for parallelism is condition parallelism. The angle between, if the two planes are parallel, angle between them will be 0. So in such cases, direction ratios. So let me just show an example. When we have two parallel planes like this, direction ratios of the perpendicular will be same, or we can say that a1 by a2 equal to b1 by b2 equal to c1 by c2. Cases, we will have a1 by a2 equal to b1 by b2 equal to c1 by c2. The parallel, if this is the case, we can say that two planes are parallel to each other. So this is the condition for perpendicularity and condition for parallelism. We get both from the concept of angle between the two planes. And as you can see from the figure, to find the angle between the two planes, we just have to find the angle between the two normals from a point to these planes. Okay, this concept will be useful in solving many questions. So please take a note of this. Thank you. The next concept is two sides of a plane. So here we have two points and a plane. So we need to find whether these 2 points are on the same side of the plane or on different sides of the plane. For that, we will be using the concept we studied in the lines segment, whether a point that intersects a line is, say, suppose we have a line PQ, and say we have a line R, and if it intersect in the ratio m1 is to m2, we can say, and m1 by m2 is positive, we can say that R intersects the line PQ internally. And if we get m1 by m2 is negative, then we can say that R lies outside, or R intersects the line externally. So say here R is here, then m1, this will be m1 by m2 will be negative. So we will be using this concept here also. So we have 2 points P and Q and a plane, and we'll draw a line joining PQ which intersects the plane, and suppose this be R. We can say that m1 R is intersecting the line in the ratio m1 is to m2, and using the same concept here, if m1 by m2 is positive, we can say that 2 points R intersect the line PQ internally, or 2 points lies on the opposite side of the plane. If m1 by m2 is negative, we can say that R in such situation, what we'll understand whether, say, P and Q are on the same side of the plane. In such situation, R will be like this, and we'll get m1 by m2 as negative. So we'll be using this concept here. To apply this concept, you'll get R will be lying in the plane, right? So let's say PB, and mention what PB, x1, y1, z1, QB, x2, y2, z2, and our plane B, ax1, sorry, ax plus by plus cz plus d equal to 0. These are the givens. Now to find R, we know that R, using the intersection concept, we can say that if these PQ get intersected like in the ratio m1 is to m2, we can say that R will be nothing but mx1, sorry, m1 x coordinates of R will be so here coordinates of R can be given by m1 x2 plus m2 x1 by m1 plus m. This will be the x coordinate of R. Similarly, m1 y2 plus m2 y1 by m1 plus m2, and z coordinate will be m1 z2 plus m2 z1 by m1 plus m2. And now we know that this point R lies on the plane, so we can apply this point on this line. So we'll get a into m1 x2 plus m2 x1 by m1 plus m2 plus b into m1 2 plus m2 y plus m2 plus c into m1 z2 plus m2 z1 by m1 plus m plus d equal to 0. We have this. Now from this can rearrange and group this as m1 into ax2 a m1 terms ax2 plus m1 term by2 plus e z2 plus we'll have one d also. If you take m1 plus m2, have m1 d here, so d 2 a 1 plus b plus c z1, or we can say that m1 by m2 is nothing but ax1 minus of ax1 plus d by ax2 dy2 plus z plus d. We can we just have to check whether m1 and m2 are of m1 by m2 is positive, means this line these 2 points are on the opposite sides, right? M1 so M1 by M2 is positive, can happen in two scenarios here. If these two have the same signs, that means if ax1 plus by1 and ax2 by2 cx2 plus d are of the same sign, and then this become a negative. So m1 by m2 become negative. So if they have opposite sign, m1 by m2 become negative into negative positive. We just so from this we can say that m1 by 2 equal to positive, or points on m1 by m2 is positive means points on opposite side. Opposite side if ax1 plus by1 plus cz1 plus d and ax2 plus by2 plus cz2 plus d have different signs. So, or points on same side if this part have same sign. So points are on the same side and points on different side we can find out using this concept. I hope it is it's clear. So we have used two concepts here: whether a point intersect a given line segment internally or externally. That concept we used here. So we can use this to find whether two points are on the same side of a plane or on different side of a plane. The next concept is finding the length of perpendicular from the point from a given point x1 y1 z1 to a given plane ax plus by plus cz plus d. So we have, I'll just draw. So we have a plane. Say we have a plane. Sorry. We have a plane and a given point. We need to find the distance. We draw a perpendicular. This distance, the length of this line segment is the distance from this point to this plane. We have to find this distance. So for this, we are going to use the concept of shifting the origin. So if you are not familiar with the concept, let me. So we have xy coordinate like this, and say our plane is here, and our point is here. 1, y1, z1. So now what we do is, this is our origin. So now we will shift our origin to this new point. So our new origin becomes this point. When shifting the origin, what happens is, so the new say x new, I will just mark x new with xn, will become x original minus x1. So here x1 becomes so to find x new, we have to subtract x1 when we shift to x1 y1 z1. To to find the new x coordinate, we have to subtract it with x1. So if you subtract x1 with x1, it becomes 0. Similarly, yn becomes y original minus y1, and zn becomes z original minus. So this is the transformation we are going to apply to every point to get our new points. So if you see, if you apply this transformation, x1 y1 z1 becomes x1 minus x1 0, and y1 minus y1 0, z1 minus z1 0. So we will get our this new point as origin as after the shift. So after the shift, the new points can be found out using this, or we can, in another way we can write this as, if you want to substitute this equation with a new equation after the shift, we need this is x original, and we need to replace x original with x new. So what is x original? From this we know that we get x original is nothing but xn plus x1, or y original is yn plus y1, and z original is zn plus z1. So we are going to use this substitution in this equation to get our new equation of the plane after the substitution. So why we are shifting the origin will be clear in few minutes. So I will just explain. So after the after shifting the origin to a1 z1, equation of new plane, new equation of the plane, equation of plane becomes a into x plus 1 plus b into y plus y1 plus c into z plus z1 plus d equal to 0. Or we get our new equation as ax plus by plus cz plus ax1 plus by1 z1 plus d equal to 0. So we got our new equation. Now what we are going to do is, we are going to convert this plane into its normal form. By doing so, we can easily find out the distance from origin, that is the new origin, to the plane. So if you know what is normal form, if you are not familiar with the normal form, you can just refer the old videos. And once we have this equation in normal form, it's very easy to find the distance from this point to the plane, or the new origin to the plane. So we'll just, to convert this equation into normal form, this has to be direction cosines. So to convert this into direction cosines, we just need to divide it with root of a square plus b square plus c square. Now this is in direction ratio form, and now to convert any direction ratio into direction cosines, say if a, b, c is direction ratio, we just need to divide it with root of a square plus b square plus c square with every term to get our direction cosines. So we'll just divide a square plus b square plus c square plus b into b by root of a square plus b square plus c square plus c by of a square plus b square plus c square z plus ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square equal to 0. Now to convert it into normal form, just bring this to the other side. So, or we get a by s. So this now is in the normal form. So if an equation is the normal form, say ax plus by plus cz equal to p, where a, b, c are direction cosines of normal to the plane, then p will be the distance of the plane from the origin. So if we have like this and a plane, this distance perpendicular distance origin to the from origin to the plane will be p. So now here we shifted our origin to this new point, and this new point is the origin now. So distance from this new origin to the plane is what we need to find. That is distance from x1, y1, z1 to the plane. So the distance we require, therefore distance from x1, y1, z1 to plane ax plus by plus c z plus d equal to 0 is nothing but this one. So since we have this has to be plus or minus ax y1 this distance will be always positive, so take this term the distance. So if you this positive and from the positive and negative sign, more information you can gather is like whether this point and the origin lies on the same side or on the opposite side. We can by looking at the this sign, the sign that appears in the RHS, we can for whether this point and origin lies on the same side or opposite side. So if a question comes like that, we can use this information to find whether whether those 2 points are on the same side or okay. So this is how we find this the equation. If you note this down, and if you some lengthy questions can come, this equation can be very useful to find the distance between a point and a plane very easily. So once you know how it is derived, even if you forget this equation, you can quickly come up with this equation in. I hope this is clear. This is how you find length of a perpendicular from the point from a given point to a given plane. Thank you. This concept could be used to find distance between two parallel planes. So I will just draw two distance between two parallel planes can be found out. So say we have one plane like this, and we have a parallel plane like this. Now distance between these two parallel planes can be found out in two manner. So say this is the origin. So first we can find the distance to this distance of this origin to this plane, and distance of this origin say to this plane. Now difference between these distance gives the distance between these two parallel planes. We can find the distance between parallel planes like this. Distance of origin to a plane can be found out using this formula we just discussed. So this is one method. Another method is just taking any point on a plane, one plane. We can easily find out one point that point from the plane by looking at the equation, and from that plane, from that point we can find the distance, distance to this. So this distance from a point on a plane to another plane will also give the distance between two parallel planes. We can use these two methods to find the distance between two parallel planes. So this is by this, like, we have discussed all the concepts that will be used in the following questions. I'll just give a quick recap. First, we discussed the equation of coordinate planes, then equation of a plane perpendicular to the coordinate axis. So equation parallel to these coordinate planes, we discussed the equation of planes parallel to. Then we discussed the concept of angle between planes. Then how to check whether two points are on the same side of a plane or different side. Just that concept. Then how to find the perpendicular distance from a point to the plane. Distance between two parallel planes. We'll be using all these concepts in the following questions. We will be solving some questions from this area. Thank you.